Can you please cross check? Yeah. But in Teams, whoever joined Teams, they are able to listen. So I don't know about this one. Is it something? This is muted, this system? Yeah. Okay, yes, I think in YouTube Live there are some problem. It's working now. Is it working now, Hemant? Okay, thanks. So the question that was asked, maybe I'll talk about that. So there are two important questions, honestly, what Manikanta has asked, and I think others have the same questions. Okay, so all these people are asking the same question. So the question is effectively that can you practically show one example with Vivado with co-simulation, a C2RTL synthesis and then optimization and running co-simulation. Yeah, I think we need to create one demo. I don't have that recorded now. And in this platform, the setup that I have now, I cannot show it because the tool is not installed in the machine where I am doing the live session. So I'll talk to NPTEL, and if they allow me, I'll just do the recording, okay, of this demo, and I can show it. It will be useful, that I understood. And then maybe the last week, I'll just add it into the list so that it will also come to you. Yeah, that's a good point, actually. The second question he has is that, can you please show how an ML algorithm is modified into hardware efficiency code and RTL code practically? Yeah. So to answer this question, your ML model is in, say, Python code, right? Keras and all. So there are two options with you at this point. Okay, so one option is I can open the, let me open and share my screen. I hope my screen is visible. Yeah, so so your ML model should work, right? Full screen. I have to make it full screen, I guess. Make on this side, no problem. Make it full screen. No, you don't. Unless you make it full screen, you make it full screen. Yeah. Oh, not this one. That is a problem. Yeah. So share the screen, yes. I have to share and then do this. So I hope my screen is visible. So for the ML models, I think this is a questions which I should explain. So you have the ML models, right? This is in basically Keras, or basically in Python, right? So So first of all, if you see this as HLS, they need C++, right? You can download this tool Keras to C. This is available in GitHub. So if you give this Keras model to him, it will give you the C++ code. Okay, I think this gives C++ code only, or C code. So now you can give it to any HLS tool, right? So Vivado HLS. Then you'll get the RTL. Okay. So it's the way I just draw. This is the overall flow, but there are a lot of challenges. Okay. So the first challenge you'll see here, this code you'll see will be not synthesizable. Okay. So what will happen here? You'll see some malloc, then function pointer, and all these things, right? So what you have to do, you have already taught in the class that if there is a malloc, you have to give a fixed memory. If there is a function pointer, you have to replace that. And if there are any STL, then you have to rewrite the code, right? So all those things you have to do in this version of the code, then only the code will become synthesizable. And because, so this is a trained model, it is not for the training, rather this is for testing, right? So, so here, the idea here is that although you'll get this code, you will see that you get a huge area. Okay, that is what we have experienced here. That whenever you try to synthesize this C code that is generated by Keras, your area is too high. Some of the common problem we face here is that, so it's a auto-generated code, right? So if probably everywhere the array size is say 1000. But you will see many places your actual loop is running for 750. So what you have to do, you have to identify those places and then you reduce the array size from 1000 to 50. Because if you make that array 1000, in the hardware, you need a RAM which has 1000 locations, right? 1000 locations. And out of the only 50 is valid, 950 is useless. So we have seen that the most of the area was coming because of those arrays, which is by default have the same size in all places, but which is not necessary by the code. As a result, a lot of area was coming. So what my suggestion is that after make this code synthesizable, you do this reduce unnecessary array size, right? Redundant array elements. So this is something very important. Okay, otherwise you will not able to get it. Then one more thing is that because these loops are very high, when you try to do the simulation, co-simulation, it will run for very, very long time. Okay. So what we have used the trip count. Okay. You just search the trip count in Vivado HLS. So what we did is effectively we use this trip count, and then using the trip count, we reduce this loops which is running for a long, right? We effectively may say that this loop you run only this amount of time. And with that, we are able to see, we don't need to run for 1000 test cases. Probably if you say run for 5-6 test cases, we'll probably understand, yeah, the model is correctly predicting, right? So with this process, you'll get some RTL, and then whatever the process, right? That whatever the C++ code, you have to add pragma, right? Main pragma you have to use is basically HLS pipeline, because this there are a lot of loops. Any convolution neural network or any ML model, these are a lot of nested loops. So if you try to run them sequentially or iteratively, it will take a lot of time, right? So what usually you should do is basically try to add pragma in all loops, and then if there are small loop, you can unroll, right? So unroll is also very useful, right? So these are the primary uh, primary optimization that you should utilize. Okay, so then you'll able to generate the RT. So this is what we usually do in my lab, or when I teach the course here in IIT Guwahati. The student utilize this, and we are able to generate very optimized design through this process. Okay, so there are little, so if you try to do first time, there will be a lot of problem. You'll see that the code is not synthesizable. You have to do it manually. Then you will generate the hardware. The co-simulation is taking very long time. So you use trip count to reduce the co-simulation time. And then you'll see the area is too high, right? Then we keep adding pragmas in all the loops and all. And there is one more thing I will suggest is very useful is merge small loops, right? Of similar limits. In the sense that limits is basically two loops, it's there and both of them running in 100 times. And they have only one operation inside, right? So this is the kind of loop which is not good actually. What will happen if let's say there are two loops which has only one single instruction. So even if you apply pipeline, now no help, right? Because there is only single operation happening inside. So those kind of loop, if you keep it unnecessary, your latency will grow. But if there is a four such loops are there consecutively, you can merge them together. Now what will happen? Now instead of 400 iterations, now so each loop is 100 iterations. So there are four loops. So 400 iteration was earlier, 400 cycles, and I'm assuming that one body of the loop can be executed in one cycle. So now if I merge together, then if I probably apply pipeline and all, probably you can actually now there will be multiple pipeline stages because there are multiple operations, and those cases pipeline will be useful, right? So we effectively utilize all these things that I have mentioned here, and through which you are able to generate accelerator for ML models. I hope this helps. Any question on this? So just to clarify about Monikanta, Sivaniram, Vaishnavi, and Dhanasri, I'll try to record one demo on Vivado HLS as you requested, and try to put into the last week video, just one more video. But I have to talk to NPTEL here, okay? But if they allow, I'll do it. And ML thing, I have already explained what to do. Okay. Hemant Srinivasa has one question here. So let me go to the question. What the question? So he gave one expression here. In this problem, I used one multiplier, one adder, two multiplier, two adder, and implement quarters prime light. Can I file this paper, sir? No. This is nothing, right? This is just so this, see, paper publication is not that easy, and don't publish any junk paper, right? Okay. So see, you have just taken a very simple you have effectively just have one expression you try to implement in hardware, and then you create multiple design for that, right? So in one design, you have used one multiplier, one adder, another design, you have two multiplier, two adder, and three multiplier, one adder. This is nothing but simple understanding the thing, right? So research paper is not that easy to publish, and don't try to publish. I have seen nowadays a lot of trend of publishing some junk paper. Okay, please don't do that. That actually create negative impact. Okay, people will say that these people are not serious. So publishing paper and you are just BTech student, there is no hurry in publishing paper, right? Who ask you to write paper, right? Nobody. People will see your fundamental knowledge, right? Whether your background knowledge is good or not, right? So research paper publication has a lot of process, and if you try to avoid that, you end up having a paper, and there are a lot of junk conference journals. You send something, they will not review, they'll accept. So those is basically counterproductive in the sense it will not add any value to your CV. Okay, so please don't publish XYZ thing. Okay, you publish something which is meaningful, which people will read. and something you really feel that this something is publishable in the sense nobody has done that work. So the first fundamental objective when you try to write papers, you have to define the problem. What is your problem statement? Okay. So that you have to define. So for example, your case, what is the problem statement? You just take an expression and you create three different architecture. So that is, so the problem statement is not clear in your work, right? Second thing is the most important thing is the novelty of your work. What is the novelty of your work in the sense? Uh, there are already people are working, right? So any domain you go, HLS, there are hundreds of papers. You have to survey the existing work and you have to tell that this is where my work is different from others or I'm adding value to the community, right? So if you cannot do that, then nobody will accept your paper in any good venue. Okay. So the first is a clear problem definition. Second thing is the novelty of your work. Then once these two are justified, then people will see the elegancy of your solution in the sense how elegantly you solve the problem. Okay, can you have a better algorithm for the problem that you're solving? Okay, or say if it's architecture paper, can you have a better architecture? So people will see the kind of architecture you are generating um, through your paper, right? And then experimental evaluation. So you have said something does not mean uh, people will accept, right? So you have in HLS domain, there are so many benchmarks nowadays. You have to take set of benchmarks and then you have to show that your method is working for big benchmarks and you are getting results uh, mm, uh, which has results, right? And you are able to show that the difference. If there are some existing work, you have to compare with the existing work and you have to show that this is the scenario where my work is working better, right? So there are a lot of process and writing paper is not so easy because you have to come into this process. When any PhD student join with me, uh, they need at least 2 years training to write their first paper. So because you need to understand the domain first, right? If you do not understand the domain, you won't able to write paper, right? So my suggestion is that don't try to be too hurry in writing papers. Your entire life is there. You try to come for internship into good IITs. You try to work with a professor who is already working in a state of the art problem. That means your problem statement is given by the professor because he knows which problem statement is novel, right? So the first two problem is already he has surveyed and defined the problem, right? For a newcomer like you, it's very difficult for you to define a problem which is novel because you don't know the state of the art, right? So my suggestion will be if you're really keen to go to research, you try to come to some good professor in IITs or any other good institute. You work on a defined problem. At least your first two step is done. You try to solve the problem. You see how to write the paper because paper writing is also needed a separate kind of training. You cannot just write XYZ and people will accept your idea, right? So all this needs a lot of time, lot of training. So I'll suggest as a learner at this point of time, you know the basic concepts. If your concepts, basic background knowledge is clear, you can rise in later, right? You can actually do good research in future. But if your background is not good, say suppose you can't code anything, you don't know the fundamental of data structure algorithms, fundamental of operating systems, networks, then you're going to struggle in every phase, right? So my suggestion is please try to clear up your background knowledge, gain your background knowledge, and your entire life is there for research and publishing paper. Okay, so is there any other questions from anybody? Please feel free to type your questions. If not more interest, then we'll wind up quickly. Okay. Hi, Kusan. Yeah. Yeah, you're in final year. Good. So is your background in electronics or computer science? Electronics, okay. So you can actually try to use HLS if you're interested in this domain for say ML architecture or say cryptographic architecture. I talked about this in the last live session as well, right? So this post-quantum cryptography, there are NIST, there is a National Institute of uh, Standard and something. So they actually have finalized two particular design, right, for post-quantum cryptography. You can take those kind of design, do HLS, you get RTL and see, then you try to optimize it. You so that you come up with some architecture which nobody is able to do it, right? And then that is publishable work, right? So similarly, um, so this I give one problem student right here, right? So you take post-quantum cryptography finalist design, try to do HLS, okay, and you'll see lot of hard work, right? It's not about taking a small code and make it synthesizable, right? Uh, you try to take ML model. So this summer I have taken around 6 or 8, I think 8 summer interns here, and I gave the problem statement is like this: everybody was given a different ML models, right? And they explain whatever I explain here, this keras to C and then ML. So I asked them to generate hardware, the basic version that take 2 weeks because there are a lot of things was not synthesizable. They were not familiar with the tool. So that takes some time. And then they try to optimize the design. And then we define a problem statement that given an area constant, that means your FPGA board is given to you. So you know what is your area. And then say you do the basic synthesis and the design is taking too much of area, right? It's not fitting into the FPGA board. Then what kind of optimization is useful for you so that finally you can reduce the area, right? So that your design get fit into the FPGA board that you have with you. Or in some cases, if your ML model is small, you may getting a design which has fit into the FPGA, but there are 30% buffer area remaining, right? So then I ask them to apply certain optimization that will improve the latency, and as a result, your area will grow up, right? So you try to identify the optimization you apply in your ML model and try to fit the design as close as possible to the area available, right? And you will reduce the latency. The problem statement was like minimization of the latency given a resource constant for ML models, right? And many of them have done very good work, right? And we collectively for intern student work, we write a paper and we have submitted in a conference. So this kind of thing happen, and you need to come into in that mode. Then only you can think about writing paper. Okay. So I think Srinivas, you understood, right? So you can actually take the similar problem statement. You can try to work on your own, so that you understand how to use HLS for practical thing, right? So I did it for ML. One problem statement is, I think not many people have explored is post-quantum cryptographic designs, right? Another domain, we had one paper, if you search in internet, image spec, right, which is come out of a course project only, right? I gave it as a course project here, and some student did it very smartly, and we wrote a paper on that. Okay, so the paper probably I'll type it here. So you can also try to think about this kind of problem statement, right? So these things will help you to apply HLS practically and can do something which is publishable. Okay, so uh, I was talking about this paper. I'll just type it here. Chat is not going. No, here it is not happening. You just put it in the chat. You type it and I will copy it. Here? Okay. So this is just one paper I'm talking about, right? So this is just to motivate you that even a course project can end up having a publication, right? This is done by Abdul here, who basically just took my course here, the C-based VLSI design course here. And I gave that year, the project was on create efficient architecture for image processing applications, right? So if you go to there are hundreds of image processing applications, right? You try to synthesize them into hardware. And he did it very nicely, and we thought it is publishable work, and we published here. So similar kind of thing you can actually think about, Srinivasa or Kusan. Kusan say that the topic for my final year project is hardware accelerator for object detection using CNN algorithm. Yeah, that's good. So you basically first create the CNN model, right? Some trained model. I mean, and then you try to use HLS. So then the whatever you learn in this course will be very much useful, right? And I have already explained the process that get us to see things, right? So I hope you have seen that, right? If you not, I'm just sharing my screen one more time. You will basically I hope you are there that time. So effectively, I was talking about that you have the ML model. So whatever the object CNN model, so this will be there. You use the tool Keras to C to generate the C++ code. Then you will see that code is not synthesizable. You try to make them synthesizable by removing non-synthesizable things like malloc, function pointer, STL. You do Vivado, you'll get RTL, but then you see that quantized this co-simulation is taking too much of time. Then you try to use trip count to reduce the uh, that loop count, and then your simulation will be faster. Then you apply different kind of pragma like pipeline unroll to reduce either latency or area, whatever is your objective, right? And also there is one useful suggestion is like you merge the small loops together. That will also improve your latency. Okay, so you can actually follow this step and you'll able to complete your BTP project, right? Whatever you final year project you're talking about, you will able to do that. Okay, so this will help, but don't expect that in one go everything will work, because there will be a lot of problems. And once you solve this problem one by one, that will help you, right? So be patient. So that will help you. Okay. I hope it is useful. Yeah. Yeah, Kusan. I mean, you can do that. It's not a big deal. And summer intern who came here, stayed for 2 weeks, 2 months, they're able to do these things, right? So it's not that much difficult. Okay. Okay. Any other questions? Otherwise, I'll wind up in another couple of minutes. Okay, so I think all questions are answered. So thank you for your time. And thank you for your interest in the course. I'm sure the course will be useful for you if you are working on anything which needs HLS. So wish you all the best for your final exam. Feel free to ask questions in the interface, the course page where we answer all the questions, right? Thank you. So there is one more question, I think, typing, so I'll wait for that. When will be the next? See, every week we see this. These are all pre-recorded one, right? I have recorded 4 years back. Every week we upload 3 lectures, right? 3 to 4 lectures. Only thing I am saying that since there is a request for the demo, there will be no live session. This is the final live session. There is no further live session. But if you have any questions, you can post into the group. We'll answer. Okay. Only thing I have committed today that if NPTEL allows me to record one more session of the demo of the Vivado HLS, that I will record. and I'll share at the last week one of the lecture note. Okay. So this is the final live session. I will not be live anymore for this course this year. If the course be offered next year, then I'll be again come live. Thank you very much. Wish you all the best. Thank you.